On rates of change. The average rate of change between 2 points on a graph is the slope through those points. We're doing slope today. And I will abbreviate that AROC, average rate of change. So if I give you 2 points, 2 random points that are on a function, and I ask you to find the average rate of change, you're finding the slope of those 2 points. So a few different ways that you will see some definitions or some formulas written out. One thing, it's a new notation for you. Probably. See a little triangle? That's delta. What that means in math is change in. So the change in your y's over the change in your x's. So if you have like a y value, one y value of 2 and the other y value of 5, the change would be 3. From 2 to 5, it changes by 3. So the change in your y's over your change in your x's. That's just something higher level math. You write delta y over delta x. That's what we'll say. Delta y over delta x. When looking at the equation of a line, what letter represented slope? Do what? Nope. What? M. Y equals mx plus b. Your m is your slope. You also learned y2 minus y1 over x2 minus x1, which is essentially the formula that we're going to use. But instead of using y when we're talking about functions, we always use f of x. Okay? So I'm not going to say y2 minus y1. I'm going to use f of a minus f of b. So if I have 2 different points, the x value, whatever's in parentheses is your x value, right? F of x, what's in parentheses is your x. So the y value at point where x is a, and the y value at my second point. That's basically the y value at one point minus the y value at the other point, and then you subtract your x's on the bottom. That's the notation that we're going to see. So let me show you. Okay. So let's say that So let's say that I'm giving you those 2 points. This x value, I'm just calling that x value a. It's probably like -3, but we're just calling it a. Then the y value at that point is f of a. It's the y value at point a, at x value a. And then right here, that would be f of b. So you've got x value a, y value is f of a. X value of b, the y value is f of b. So when we're asked to find the average rate of change, and I give you an interval, I'm giving you the 2 x values. So if I say find the average rate of change over the interval 2 to 5, I'm asking you to find the slope from x value of 2 to x value of 5. And so you're going to find the y values of the function. So we're going to find, we have to find those the 2 y values by plugging in x to my function. I'm probably going to give you a table or a graph or an equation. You find the y value, and then we just find the slope. We do the slope formula. So, number one, I just went pretty straightforward. Find the average rate of change between 2 points, the point 1, 2 and the point 3, 4. Now, I know you can do it real quick, but we're going to start by using the notation that I gave you. So, for example, my first point, that would be my A is 1. My A is 1. And f of A, that's the y value, is 2. My B is 3. What's f of B? 4. So A is your x value, f of A, y value. B, your other x, f of B, your other y. So the formula is f of A, what's A? My first A, or my only A, 1, minus f of B. What's B? What's B equal? 3. Over A minus B, 1 minus 3. So we're finding, it's a lot of notation that when I give you an example with just 2 points, it's like, why can't I just subtract the y's and subtract the x's? That's what we're doing. You've got to get used to this notation. Stuff that you've not seen in your math classes yet. Okay. So this would be 2 minus 4 over negative 2. You got to be able to do this right here without your calculator. Like this question specifically. There may be questions that have really ugly numbers or really ugly equations. Those, of course, would be on a calculator portion. This would not be. This probably is not going to be on the test anyway. But 2 minus 4 is negative 2 over negative 2 equals 1. You also have to show every step. Number one, that's just what they expect on the AP exam. Number two, they can give some partial credit. They give you, they have a rubric. If you've been in an AP class before, you know they have a rubric. They're looking for certain things. If you don't show every single step, you're likely to miss those certain things that they're looking for. They can't even begin to look at your thinking if you don't show every step. So yeah, could you have thought of this in your head and just got equals 1? Probably. Don't do that. Write it out. So the average rate of change is 1. Okay. Number 2, find the average rate of change on the interval from 13 to 25. So I'm looking at those 2 points. Top number is basically your x. Bottom number is your y. So what's my A going to be? 13. You could have picked 25, 13 or 25, it doesn't matter. So f of A, what's the y value when x is 13? 76. So then that means my B has to be 25, and my f of B equals 30. We're basically writing out our 2 different points, the x and the y. And so then my formula, f of A, so f of 13 minus f of 25. Right here, you probably would be okay to go ahead and just put 76 minus 30. You probably could get away without writing this first step. Go ahead and plug in your f of A. So 70, f of 13 where f of A is 76 minus my f of 25, 30. What's 13 minus 25? Got to get that without a calculator. Negative 12. All right. Without a calculator, what's 76 minus 30? What? 46 over negative 12. This is not going to go evenly. So it's just going to be a simplified fraction. If you might just keep like, oh, those are both even numbers. Divide them both by 2 and then see if it simplifies even more. This would be 23 over negative 23 over 6. It doesn't go down anymore. Yes.
Like, if it's like this, they're going to have like the answer that has a fraction.
If it was multiple choice, yes. You're probably not going to see nearly as many decimals. And this question would have been a non-calculator based. They would expect you to simplify a fraction, not give a decimal without a calculator anyway. So, all right, number 3, find the average rate of change over the interval -1 to 3. All right, so my A is -1, my B is 3. So my A is -1. All right, so right here, when X is -1, what's the Y? When X is -1, what's Y? 0. B, that's my second X value. I mean, it's marked. They've got the lines drawn in. What's the Y value when X is 3? It looks, yeah, it's kind of hard to see, but 4. So if we do, that would be f of -1 minus f of 3 over -1 minus 3. So f of my A minus f of my B over A minus B. 0 minus 4 over -1. Well, you can go ahead and put -4 down there. -1 minus 3 is -4. And this would be -4 over -4, which is 1. Now, the instantaneous rate of change. Instantaneous means at that exact second. I might ask you to find the instantaneous rate of change, but I only give you a single point. I don't give you an interval. I want to know the slope at that exact point. We don't really have a good way of doing that right now. So the best way to get the closest answer is we're going to do the average rate of change at very small intervals. Meaning I'm going to do the average rate of change, but I'm going to make my interval so small, like not even 1 apart. Like maybe from 1 to 1.00001. Okay, so the closer they are, the closer your interval is, the more accurate your rate of change would be at that exact moment. So I've given you this. A ball is thrown vertically in the air for the interval 0 to 5. The height of the ball, or for the interval 0 to 5, the height of the ball is measured by this. I'll give you the equation. Blah, blah, blah. Find the average rate of change over the given intervals. So right now I'm not asking you for the instantaneous because I want to show you how being off from 1 to 1.1, you're going to get an answer that's different than 1 to 1.01. So we've not done equations yet. So this is my x value. The first one is my a. We plug that into the equation to find the y value. So if I do a is 1, then f of a would be negative 4.9 times 1 squared plus 25 times 1 plus 5. We're going to run out of room. Yuck. Equals. All right, you will have to have a calculator for this. So if you didn't grab yours, grab it. No. I'm going to show you a little time saver using the store button that we've used in class before. We're going to be using this same equation several times, so the store button will end up being faster. So if I do 1 store x, okay, and then I'm going to type in negative 4.9 x squared plus 25x plus 5. And then from now on, when I store a new number, I can just go back up and select this equation and it'll bring it down so that I don't have to type in the whole thing every time. We get 25.1. Okay. And then, so that's my A, that's my B. So then f of b is negative 4.9, 1.1 squared plus 25, 1.1 plus 5. So I'm going to plug in 1.1 to get my second y value. Or x. And then I'm just going to go up until I highlight that and hit enter, and it brings it back down. So I have both of my x's, both of my y's. And now I can find the average rate of change. So it'll be f of 1 minus f of 1.1 over 1 minus 1.1. So it's f of a minus f of b over a minus b, which is 25.1 minus 26.571 over 1 minus 1.1. I would go to alpha y equals. We do not round right now, which you're working ahead, or decimals get longer. We don't want to round just yet. So you got to type in the whole number. And you get 14.71. So the average rate of change at that interval is 14.71. Now, to save space, don't worry about writing all of your work out. And actually, all of these other three use 1. So you don't have to find f of 1 again every single time. You've already got that. We already know that f of 1 is 25.1. So on this second one, the only other one I need to find is f of 1.01. So I already found f of 1. So I'm going to do 1.01, store x, and then go back until I've highlighted that equation and hit enter. Hit enter again, and it gives us that. So I have everything I need to find my average rate of change, or my slope. I have two x's, 1 and 1.01, and two y's, 25.1 and that 25 point da 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 da. So to find the average rate of change, we do the fraction. The y's are on top. So 25.1 minus, let me show you this, 20. I think, so especially if you have a long decimal, if I arrow up and highlight it and hit enter, it puts it back where my cursor was. So you don't have to retype the whole thing. Over 1 minus 1.01. Alright. So those numbers, I mean, in the world of pre-calculus, those numbers are pretty far apart. Now let's do f 1.001. 1.001. Store x. And we get an even longer decimal. I'm not going to write the whole thing. Okay. I'm not going to write it all, but when you type it in, you've got to put the whole thing. So my average rate of change, my first x, so I got 25.1 minus, I'm going to go highlight that so I don't have to retype it. Nice. Over 1 minus 1.001. So we're getting, these aren't as far apart, okay, as the first two. The more precise your interval is, the closer you'll be. Now, the last one we're going to do, this one gives us a little section before 1. What we've done is a little bit after 1. Okay. So we're kind of doing a little bit to the left and a little bit to the right. So we've got to do 0.999, which is very, very, very close to 1. And we get 25.0847951. Okay, so my average rate of change would be Now on my interval, it lists the 0.999 first, so I would go with that one first. It does not matter if you do the 25.1 and the 1 first, as long as they're together. You either do them both first or you do them both last. Okay, so that minus 25.1 over 0.999 minus 1. 15.2049. Alright, so we have found the average rate of change, little sections really close to 1, but we couldn't do exactly 1. Now, a little bit to one side of 1 is 15.195. On the other side, it's 15.2049. What do you think would be the true instantaneous rate at 1? Somewhere between those two. What would you say it would be? 15.2 is what I would say. So, a little bit past 1, it's just under 15.2. Here, it's just over 15.2. So we're estimating. We can't say for certain, but I would estimate 15.2. That's about in the middle of those two slopes. All right, we'll finish this right here, and then we'll finish the rest of it tomorrow. So the graph of F is shown along with the line. Here, I'm going to give you a fancy new word, the line tangent to F. A tangent line is not the same tangent that you learn about in trig. A tangent line means it's the line that just touches the graph without actually crossing over into it. Okay, so we draw little tangent lines. It just means it touches the graph. So at this tangent line, could you guess what that slope would be? I mean, it's hard to see the lines. This looks to be the point -2, 5. -4, 2. So this one, if you're just thinking rise over run, this one goes up 3, right 2. So we would say that the average rate of change right there is 3 over 2 because that's the slope of the tangent line. Now your tangent lines are never going to be perfect. They're kind of hard to draw. So if I draw a tangent line over here, I want to draw a straight line that just touches at this point. Okay, it doesn't actually cross through, which is about like that. The shorter that you draw them, the easier they are to draw. Okay. And then that one, and then that one. Okay. So as I go down, follow down this function, these little tangent lines, just the little lines, all these little dashes that I've been drawing, I'm basically drawing little tangent lines. Just whatever the slope, the little line looks like there. So if I keep going up, about like that. Of these 2 points, or those 2 points, which of those do you think the tangent line or the slope is greater? The first one or the second one? First one or second one? Which one has a greater slope? The second one has a greater slope. They're both in the positive direction. This one looks a little bit steeper, so it's greater. So you may not be able to say that's exactly, the slope of this line is exactly 7. We don't know that, but you can kind of estimate and you can compare them and say, well, this one is definitely steeper, so it's definitely greater. And we have just some practice examples, and that is one thing we're going to have to do on the back, is look at the slopes and figure out which one's greater. Okay, we'll stop there for today.